Okay, sorry about that. I'm just going to see if I can get the pen back. Where is that pen? Let's see. I'm going to try to get the pen back. So there you go. Sorry. And the way that this works is we have a couple of questions here. Sometimes you're going to be asked, is the consumer maximizing their utility? Another question is, if the consumer has a certain budget restraint, what is the combination that maximizes the utility? So I can see some data here. I have the quantity of apples and I have the total utility. So for the first apple, this person is getting 20 utils of, 20 utils, kind of 20 happiness points. For 2 apples, a total of 35. For 3 apples, a total of 45, and so on. I can create a column here that's basically marginal utility. Sorry, this isn't going to be super neat, but when we're coming up with marginal utility, what I like to do is put a little line so that way you can think of marginal utility as the change in total utility. So the change in total utility between 0 and 20 is going to be 20. That's the marginal utility. For the first apple, you're earning a marginal utility of 20. For the second apple, your total utility is increasing from 20 to 35. So you have a marginal utility of 15. Sorry, this is like looking wacky because I'm drawing this with my little mouse. And then when you do 35 to 45, your total utility is increasing, but we're seeing our marginal utility is actually decreasing after the consumption of the first unit from 20 to 15 to 10. So this is where we would say in this section, all the way up to the 4th unit, here we have a increase in total utility, but the marginal utility is 5. Okay, what this suggests is we have total utility is increasing, but marginal utility is decreasing is decreasing. Total utility is increasing at a decreasing rate. The other thing we can note is that marginal utility is kind of telling us about our preferences. How much do we really like this particular good? We can also do marginal utility. We can do a column here, marginal utility. And we'll just put marginal utility for oranges here. And in this case, we're going to have a marginal utility of, this will be 30. Sorry, my mouse is like acting odd. That's a little tricky to do. 30. This will be 20. This will be 15. I'm sorry. Yeah, it is 15. Sorry. Okay. I don't know. It's really hard to kind of draw these numbers neat. And this is going to be 10. All right. And I'm not going to do the last two, but you get the idea of how you would create the data of marginal utility. If marginal utility was the only thing that mattered, like we were only interested in marginal utility, you would say to yourself, you know what, I would buy the, which one would I buy? I would buy the orange first, right? Because I like it better. I get 30 utils compared to 20 from the first orange compared to the first apple. But because we're interested in marginal utility per dollar, for every dollar that you spend on the good, how much additional utility do you get? Well, for this column here, marginal utility per dollar is going to be the same because each good is only $1. So MU per dollar is going to be 20 for the first one, 15 for the second, 10 for the third, and so on. This, however, is not going to be the same. Your marginal utility per dollar is going to mean you're going to have a whole nother column where you're going to divide these numbers in half. Okay, so marginal, if you get 30 utils for every $2, you get 15 for every $1. This is going to be 10. This is going to be 7.5. And then this next one is going to be 5. Okay. So this one will be 5. And then this gives you comparison that you can actually make that's reasonable. What is your marginal utility per dollar for the first apple versus the first orange? And you kind of just look at this as you go shopping. you buy, you look at the first unit for each good, and you keep purchasing units until two things happen. One, you maximize your utility and you spend your entire budget. You're not maximizing your utility unless you spend the entire $7. We're told that this consumer is going to maximize their utility when they spend it on apples and oranges. So we can't assume that like saving the $7 is better or that buying something else is better. It's not about our personal likage of, apples and oranges. It's really about this consumer. So I can see based on my marginal utility per dollar, first I would buy the apple because I get a marginal utility per dollar of 20. And that's the highest, right? The first apple is a much greater marginal utility per dollar than the first orange. After that, and I've already spent $1, so now I'm down to a budget of 6, right, instead of $7 because I just spent $1. Now I'm kind of indifferent because the marginal utility per dollar of oranges is 15. The marginal utility per dollar of apples is 15. So let's assume I buy the second apple. Now I've spent $2, and I also buy the first orange, okay? So I would buy the first orange before I would buy the third apple because the first orange gives me greater marginal utility per dollar. At this point, I've spent a total of $1, $2, $3, $4, okay? Now I go to the next one, and let's say, okay, I'm indifferent again. I'm going to go to the second orange, okay? So I spent $4. Now plus $2 more spent, I spent a total of 6. And I'm going to come on over here and buy this third apple, and that third apple will cost me $1. I will have purchased a total of 3 apples, okay? So 3 check marks, 3 apples, and 2 oranges, okay? Circle like our 2 oranges here, 2 oranges. So with a budget of $7, with prices $1 and then $2, my utility gets maximized when I purchase a total of 3 apples and 2 oranges, because the last apple and orange that I purchased, the third apple, gives me a marginal utility per dollar of 10, and the second orange gives me a marginal utility per dollar of 10. Okay, those have to be equal. If I get a greater marginal utility per dollar of oranges, then I would buy more oranges. Okay, that is really the essence of the utility theory. We could try another one. This one is like a nice one because the data is already set up for you. So in other words, let's see, I think I can put the pen back on. In this case, before we were given columns of total utility, we had to figure out marginal utility and then marginal utility per dollar. Here, we're actually given it, okay? And it's very similar, okay, because it's just different data, but it's a very similar problem. Okay, so I'm going to put a little mark down here. I'm looking at apples and I'm looking at oranges. Apples are $1 and oranges are $2. And the way I would do this, okay, because now I know my marginal utility, I like oranges a lot more than I like apples. So I would buy this orange, this orange, this orange, except prices also matter because oranges are $2 and apples are $1, okay? The first apple, so marginal utility per dollar, the first orange would be what I would buy. Then I would buy maybe the second orange, okay? I've spent a total of $4. In this case, the consumer has $10, okay? I would buy the first apple. Then I would buy the third orange because I'm looking at a higher marginal utility per dollar and I'm spending money, right? 1, 2, 3, 4, 5, 6, and then $7. I could buy the fourth orange for an additional $2. My marginal utility per dollar is 8. I could buy the second apple for a marginal utility per dollar of 8. That second apple is equal, like the marginal utility per dollar of 8 and 8 are equal. So the last apple and the last orange that I put into my cart have equivalent marginal utility per dollar. Okay, so that's good. I've also spent my entire budget, right? $2 on apples and $8 on oranges, okay? I'm just going to flip to the last slide, and I'm going to note this, and it's a little bit odd, but see if this makes sense to you. When we had apples and oranges, right? Kind of assume that we're looking at how do we get the data on the demand curve, and we can actually derive a demand curve from some of the consumption information we're given. When we pose oranges and apples in relation to each other, and the consumer makes decisions about how many oranges to buy, it does depend on the price, because inherently in the theory is margin of utility per dollar. We're interested in the higher the price, the lower that fraction is going to be. So what we can do here is imagine that if oranges are $2, right, we know that the consumer demanded 4 oranges. Okay, this was in the last slide, right? 4 oranges when the price was $2. So whenever the price was $2, the quantity demanded is 4. That's a point on the demand curve. If I lower the price of oranges, and notice I'm only doing a demand curve for one of the goods. I'm not putting a demand curve for apples and oranges on the same graph. I'm just taking out oranges and saying, okay, when the price of oranges is $2, how many oranges might I demand? It's 4. When I lower the price to $1, okay, what I would have to do here is I would have to go back to this data and say, okay, what happens if I do it this way and my I no longer have this column because the price of oranges is no longer $2, now it's $1, okay? What would I buy first? Okay, well now I would buy the first orange, right? I'd buy the second orange. I would buy the third orange. I'd buy the fourth orange. I'd buy the 5th orange. So I'd buy 5 oranges, $5, 5 oranges. I'd buy the first apple, and I'd buy the second apple, and I'd buy the third apple, and then I'd buy the 6th orange, okay? So at that point, I have spent 1, 2, 3, 4, 5, 6, and then I would buy the 4th apple. My margin of utility per dollar, my margin of utility per dollar is the same, okay? And I also spent my $10, okay? And I can go back to my demand curve and I can say, okay, how do I kind of interpret some of this? When the price was $2, I only bought 4, right? When the price got lower to $1, I actually bought 6. So some of the data that we're always plotting on the demand curves is coming from the utility maximization, formula, okay? This is a practice problem you can do. This is already on the sheet. We can go over some more, but this is mostly what we talked about in class, okay? So bring any questions you have, and